Bitswaran. Today we will see materials in nanotechnology. So this is included in engineering materials. So nanomaterials, so we can find in many applications nowadays. So the American physicist and Nobel Prize laureate Richard Feynman introduced the concept of nanotechnology in 1959. So these are the examples: graphene, nanotubes, nanofibers, nanowires. So these are the examples of nanomaterials. So we can find natural organic materials in our daily life, like human hair, our own bone matrix, paper, feather. So these are the natural organic nanomaterials. So inorganic nanomaterials can be found from the earth crust. So also from forest fires, volcano ash, ocean spray. So from these sources we can find the nanoparticles. So now we will see metal nanoparticles, crystal nanoparticles, semiconductor nanoparticles. So in the metal nanoparticles, so copper nanoparticles lesser than 50 nanometers exhibit high malleability ability than bulk materials. So the mechanical, optical, chemical and electrical properties are main importance. So in nanoparticles, so we can get good mechanical properties for the materials at atomic level than bulk materials. So we have one-dimensional nanomaterials, 2D nanomaterials. We can also get nano compound particles at three-dimensional as nano composite. So as I have already explained, different nanomaterials. So graphene, nano carbon nanotubes, nanofibers, nanowires. So the manufacturing methods are vapor deposition methods and powder metallurgy technique, compression molding, synthesis of materials. So these are all different manufacturing methods. So we can find the nanomaterials application in different areas like electrical and medical, many areas. So we also know biomaterials. So there are also the applications of nanomaterials. So gold nanoparticles appear deep red to black in solution. So means, so the gold is, so this is about color, but so at the atomic level it is showing different properties. Also its mechanical properties like elastic modulus, hardness, surface roughness and other mechanical properties show better, even 3 to 4 times better than its bulk materials. So that is the advantage of materials at their atomic level. So semiconductor nanoparticles. So the three key steps here I have mentioned: materials preparation, property characterization, device fabrication. So first we have to prepare the materials, property characterization. What properties we are getting? So fabrication. In the next step it is fabricated by different manufacturing methods. So about semiconductor nanoparticles. So synthesis of semiconductor nanoparticles is significant, means important. So here titanium dioxide, zinc sulfide, zirconium oxide are employed as photocatalysts. So we can compounds. So nanoparticles include compounds of elements in groups. Second and sixth group has one compound. Second and fifth group is another compound. Fourth, one material from fourth group, one material from sixth group. So these two are compounded to form one semiconductor nanoparticles. Here we have titanium dioxide, zinc sulfide, zirconium dioxide. So these semiconductor nanoparticles are employed as photocatalysts. There are other different semiconductor nanoparticles or nanomaterials are there, like other sulfides, tungsten oxide, cadmium sulfide. So other sulfides are there. So the applications of semiconductor nanoparticles are nanoelectronics, non-linear optics, imaging devices, solar cells, biomedicine, etc. So the synthesis. So from nanoparticles include compounds of elements in groups 2, 6, 2, 5 and 4, 6 within the periodic table. So this is about the semiconductor nanoparticles. So it is used in sensor devices. So this is about semiconductor nanoparticles, metal based nanoparticles, crystal or non-crystal nanoparticles. So this is about introduction, different types of nanomaterials, its manufacturing methods, applications, so properties, how they will behave, how they will behave, what are when more research work is saying. So the materials have better properties when it is made nanomaterials. So it may be for copper, gold and other materials, and in semiconductor nanoparticles also most of the materials, it may be in semiconductor nanomaterials, metal nanomaterials, crystal nanomaterials. Most of the materials exhibit good properties when it is made nanomaterials than their bulk materials. So it is not about the properties, it is also finding its extensive uses in many fields like electrical, biomedical, electrical and many fields. So this is brief about nanomaterials, different types of nanomaterials, applications, and so we will see more deeper into the topic in the coming class. I hope this is clear.